Kia ora koutou. Hello, konnichiwa. My name is Charlotte Brown, and I am the director of a small research and consulting company in New Zealand called ResOrgs, and we deal with risk and resilience and are part of the research ecosystem within New Zealand. Thank you very much for having me here today, to have the opportunity to share some of the great work that's happening in New Zealand and to deepen the collaboration between New Zealand and Japan. Today I'm focusing on how we make all our hazard and risk loss modelling really connect with what it means for people and businesses. So I think it really resonates with the introduction that Professor Kusunoki gave this morning, which was really about creating information that means something to people. My presentation today is a collection of research from across the country, from a lot of different researchers and a lot of different institutions. I've got a lot of QR codes that are on the slides, so you can connect to the detail of the research if you would like to. Or equally, you can talk to me and I can help with those connections if I'm not directly involved. So in terms of the progress of my presentation today, I'm going to start by focusing on how we understand service loss through time. So I'm going to take up where Ryan left off and move beyond the direct impacts to think about the indirect impacts through time. And the second part of my presentation will be about the social impact. So what does loss of service through time mean for people, and how do they behave in response to that? Then we'll look at the economic impact, which it moves beyond the direct impact to think about how does disruption cascade through the economy. And I'll finish up with two short sections, one on risk tolerance, so understanding which risks we want to manage and which we'll accept, and then a little bit around community engagement activities in New Zealand. So the first is just an overview when I say asset to service loss modelling of what I mean. So the loss modelling pipeline, the hazard and loss modelling pipeline, is fairly well established. This first part, which really aligns with what Ryan presented this morning, is about understanding the direct impacts. It's about identifying the hazards that we're looking at, how intense those hazards are across space, thinking about what assets or parts of built infrastructure and people those hazards might affect, so the exposure, then understanding how, based on the exposure, how vulnerable those assets are to failure, and then all that generates the direct physical impact. So it's a fairly well established modelling pipeline. Of course, in New Zealand, we're always doing work to improve our understanding of each of those stages, and Ryan gave a really great presentation around how we're doing that for flooding. So understanding that hazard better, but also understanding the fragility of those assets. And we've got a very similar program happening in New Zealand around landslide damage at the moment, and we're continually trying to grow our library of fragility functions so that we understand what hazards can do to our infrastructure. So what I'm going to focus on today is the next steps. What then? What does this mean for people? The first phase of that is understanding a bit more about what those direct exposure and direct impacts mean in terms of service loss to people. So this includes considering interdependencies between infrastructure and also understanding asset restoration through time, so then we can understand who might have infrastructure service through time and across space. And the last phase of that is is social impact and economic impact. So based on the loss of service, what does that mean for people? How do people behave when they have a loss of service. What do they do? Do they stay in their home? Do they relocate? How do businesses respond? Can they continue to operate, or do they have to cease production? And then how does that impact cascade across the economy? Okay, so I'll start off with service loss through time and focusing on those interdependencies and asset recovery. So this work here is being led by Logan Brunner at the University of Canterbury. And Logan is looking at interdependencies between infrastructure systems at a city level. So his case study is Christchurch, and he's looking at the interdependencies between electricity, water and wastewater networks. And what his research is showing is that if we just look at those direct impacts, so those assets that are directly impacted by the hazard, we might be underestimating the impacts by 3 times. So his work is looking at what does it mean if certain assets are disrupted, how does that cascade around different infrastructure systems causing, so in this case, disruption to electricity, meaning that water provision might be compromised or wastewater systems might not work. Mitchell Anderson, also University of Canterbury and now Urban Intelligence, has built on this model alongside this model to develop something called a functional isolation model, which looks at different types of industries and what might happen to those industries in terms of their ability to function based on the kind of disruptions that they experience. So that could be direct loss of infrastructure, it could be the physical disruption themselves, but it could also be things like supply chain disruptions or access restrictions, which might affect customers coming to a business, or it might affect staff being able to come to their business. This is a really critical step in us moving from understanding what it means for the asset damage to understanding what it means for businesses and households and their ability to operate. So within that, I mentioned supply chain disruption. So there's a bit of work happening at the University of Waikato, funded by QuakeCore and led by Cecile Dermit, looking at the vulnerability of freight systems to disruption. So this is a qualitative study which is looking at post-disaster constraints in the domestic freight system. In particular, it's looking at the impacts or the potential disruption to the delivery of perishable goods, so fruit, vegetable, meats, fresh meats, and it's looking at how the quality of those products might be impacted, the timeliness of delivery, whether they get to the right place on time, and the cost of delivery. It's looking at all the potential root causes of those disruptions so that we can better understand where in our system we need to focus in on our efforts to improve the reliability of the freight system. So she's using a theory of constraints and a current reality tree for that. So understanding this is really helpful both from a policy intervention perspective, but also from increasing our ability to adequately model disruptions to freight systems. Also at the University of Waikato, led by Nadia Trent, is some work quantitative work, looking at the change in behaviour of freight companies before and after a disruption. So they're using telemetry data spanning 6 months before and after Cyclone Gabrielle, which has been mentioned previously, and looking at how the patterns of freight vehicles change through time, and then marrying that to the roading disruption so that we can understand the different choices freight companies are making, so that we can then use that understanding of that behavioural response to inform models, such as a first iteration of a freight transport model for New Zealand, which we're beginning to work on in the next couple of years. So some more modelling led by Logan Brunner at the University of Canterbury is looking at infrastructure recovery through time. So as I mentioned, infrastructure interdependencies are really important to understand, but even perhaps more important is understanding how long people's service is affected for. Because the impact of a one-day disruption is very different to a 20-day disruption. So here, Logan's looking at the restoration of an electricity system after a flooding event in North Canterbury. They're using an optimization model based on the number of crews that are available to fix faults and sequencing those fault repairs, and then that feeds back into the service available over time and through space. So in my view, this step here, this recovery modelling step and understanding how long it might take to get services up and running, is the missing step in our ability to do end-to-end modelling from hazard through to social and economic impact. And particularly to be able to do it in an automated fashion. We've been doing it in New Zealand for a few years, but this step has always been a manual process. And there's significant work that's needed to improve the quality of this. The last slide here is showing some work from Urban Intelligence led by Tom Logan, which is looking at isolation of critical services. So this is really building on the work that I've just presented, trying to think about how might people start to understand how they are disrupted by these different impacts. So this dashboard or interface, the current example that's here is looking at isolation from fire stations. So what it's trying to show to a local authority or potentially to community members, to show them where what areas might be isolated from access to firefighting services, so where they might be vulnerable. At the moment, it's I'm pretty sure it's a static model, so it's just looking at one point in time, but they do have other versions of this where they're looking at that disruption through time. So I think that has some connections to what you're trying to achieve in the SIP program, and trying to think about different ways to communicate that disruption to households, businesses and government agencies as well. Okay, social impact. So what does that mean in terms of impact to people? So we've got a number of projects that are happening here at the moment in New Zealand, but I've just chosen to highlight a couple here today. The first study is led by Min Q at the University of Auckland. And Min is using mobile phone data to understand consumer behaviour changes after a disruptive event. Again, he's using Cyclone Gabrielle here to test this Hawkes process modelling approach. But effectively what the modelling does is it looks at consumer behaviours and matches that to what industries they are visiting, and then it can simulate the recovery of different industries through time and location as well. And then that can be matched up to what the disruption is in the roading network, so we can understand what might be led by the disruption to the assets and what just might be led to the necessity of getting to different industries. The graph on the right-hand side shows one of the potential outputs of this work, which shows the different recovery rates of different industries. So you might not be able to see the small text, but at the top is education. So education is the first thing that people are prioritising getting back to. And then the different services cascade down that. So this data has practical use in understanding how events impact us, and that can then feed into transportation disruption models, and it can also impact how we might think to support different industries in the recovery after an event, in terms of managing, mitigating their demand changes. This research here is led by Finn Shield at the GNS Science. So Finn's really looking at the issue of what households do under severe disruption. His stay or relocate model is about the decisions that households make to stay in a disaster-affected location or to relocate elsewhere. It's an agent-based model, which has some empirical modelling behind, or data behind the model, but it also has a lot of expert judgment. There's a lot of work that could be done to provide empirical data to support the model. Effectively, what it does is it looks for any given household. It combines the type of disruption that it might be experiencing. So the habitability of the house itself, the disruption to services that people within the house might be interested in, so schools, water and electricity disruption, general community and neighbourhood disruption, supermarket access and the like. And then it combines that with the household demographics, because different types of households are going to react differently to these disruptions. Some will be more mobile and some will be less able to move. And so the agent-based model then combines that to create decisions around what they do in terms of whether they relocate or they stay in place. And then the second part of the model is the relocation element. So if the household decides to relocate, where are they likely to relocate to? So this has some really strong implications, or might help emergency management planning, so that you might be able to anticipate how many people might need emergency housing, or understand where people might go as well, whether they stay in region or they go to another region. So Finn has applied this to a hypothetical Taranaki volcanic eruption scenario. And this graph here sort of shows the outputs of the model. So you can see the number of people that they anticipate being displaced through time. And you can also look at what are the key causes for that displacement, which is really helpful in understanding what might be the most important disruption to mitigate or to reduce the number of people who are leaving their homes. And the other side of that is based on knowing how many people are leaving, where they might be going. So again, that's where you can see it might be helpful to understand who needs temporary accommodation and who might be moving out of the region. As part of this work, a dashboard or an interface has been created that is being used in emergency management planning. So it looks at the number of households that might be displaced and who might need temporary accommodation, as well as some of the inputs in terms of how many people don't have water and wastewater or other critical services. So those are just a couple of examples of how we're looking at behaviours around, once we know what the direct impacts are, what does that mean for people's responses. So all of that is really useful to feed into an economic impact model. And here, when I'm talking about economic impacts, I'm not talking about the direct impacts, so the cost of the damage. I'm talking about the impact on the economy, so the loss in the GDP or the gross domestic product. So over 10 years ago, we began the development of MERIT, and it's now an operational model. So MERIT is the modelling of economic resilient infrastructure tool. And I'll just talk you through what MERIT does and a little bit about the details of what it is. So MERIT, it allows us to estimate the economic impact through time. It takes the direct impact. So rather than, it doesn't take the direct impact, it takes the indirect impacts. So it is based on the loss of service through time. So the critical input for MERIT is understanding the disruption of all the different infrastructures through time, as well as other things like damage to buildings, impacts on the community, which might impact the availability of staff, and disruption to supply chains and the like. So based on this critical input of disruption through time, we estimate how likely it is that different industry sectors are able to operate and how quickly they recover through time. So the business operability function, or the business behaviours module, is designed based on survey data, so empirical survey data following the Canterbury earthquakes. It was designed in a way that it could be used in a hazard agnostic model, so we can apply it to any hazard, but of course it's limited by the input data. We've definitely got more work to do to improve those assumptions, but it's a good, the structure at the moment seems to be working. What we also have done within Merit, then this was before Finn Finn developed his storm model. We've developed a little bit of a function looking at people and business relocation. So trying to estimate how many people might be leaving the region, how many businesses might leave the region, and then whether or not they come back and at what stage or what time they come back. Also within that model, we can incorporate demand side impacts, so things like tourism. So in New Zealand, tourism is our second biggest industry. So it's really important that we capture the impacts of that in our economic modelling. And then all of that flows into the engine of Merit, which is a dynamic economic model. It's built on a computable general equilibrium model format, but it is designed in a system dynamics framework, which allows us to see disruption through time. So unlike other economic models which kind of force the economy into an equilibrium, this allows us to see how it changes through time and allows it to oscillate and move to a new equilibrium, a post-disaster state. And then the output of this is the economic impact through time. So just to show that in a bit more of a dynamic sense, so we take all the different disruptions. In this case, we're looking at population relocation and roading outages through time. We combine those, and based on the combination of different disruptions across space and across time, we look at how businesses are able to produce their goods. And then the output is there's lots of different measures we can report on, but here we're looking at the different value added or changes, or the GDP changes at industry level through time. And you can see the different bars because this particular example is taken from some work we did with the Wellington Lifelines group, so the group within Wellington that I guess try and manage some of the infrastructure in Wellington, and we were looking at a business case, and the green bars are showing what is the value, what is the potential impact if we don't invest, and the yellow is what the benefit or what the reduced losses would be if we invested in certain infrastructure investments. So that was a really quick tour around our efforts in New Zealand to get that end-to-end modelling from the hazard through to the social and economic impact. And really our efforts to do that are in no small part about trying to make more effective disaster risk management decisions. And so that could be risk decisions in the response to an event, or where we in New Zealand tend to use this is in the investment business case, trying to decide where we should best invest in mitigating disaster impacts. So another element, as well as understanding the impacts of potential events, to get good risk management decision making, it's really useful, we think, to start thinking about risk tolerance. In New Zealand, we have limited resources and a lot of priorities, so really having good conversations about how we make these investment decisions is really important. And the other element is that community engagement. As Sarah Jane said this morning, involvement of community is really central to how we manage hazards in New Zealand. So it's a big part of what we do. Okay, so national risk tolerance. Some work we've been doing at the moment to really understand how, across all the different applications in New Zealand, we think about how we manage risk, and we choose, we make decisions around when to mitigate and when to accept risk. I think that, as Sarah Jane said this morning, there's not a heck of a lot of consistency across how we do that in New Zealand. It's a very complicated space with a lot of different agencies and a lot of different legislation and priorities. And these are covering a whole range of purposes. So regulation design, policy, both internal, organisational and external, built environment design standards, emergency management planning, land use planning, climate change adaptation. And these things are happening across community level through to national level. And at the moment, we really don't have any consistent approaches to how we talk about risk tolerance. So Sarah Jane and her team at Natural Hazards Commission developed a risk tolerance framework to help us think more explicitly about how we consider risk tolerance in our risk management decision making. And it's been a really, really great conversation starter to make people more conscious of this idea of making good decisions about which risk we manage and which we don't. But some people have struggled to apply it because there aren't good guidelines or frameworks in place to support the implementation of it. So we've developed a national working group around this to look at the different ways we could support risk tolerance conversations and decision making, and have identified a number of priorities, which you can see on the slide there. And effectively what we're moving towards is some centralised guidance and a nationally agreed framework for how we do this, how we have conversations and how we evaluate and apply those risk tolerance settings. I just wanted to quickly highlight one of the projects that we have been starting to have a conversation about national risk tolerance, and that's the Resilient Buildings project. A few years ago, the New Zealand Society of Earthquake Engineering, funded by the Natural Hazards Commission, undertook some work looking at community expectations for the performance of buildings. And this was as a sort of foundational work to inform ongoing building code and policy design. So the research showed, unsurprisingly, that life safety is still the highest priority among community, but there's also this increased realisation that having better performing buildings is going to mean better social recovery and economic recovery after an event, and that is increasingly important. There's a little bit of priority given to minimising environmental impact, but that's still definitely last place at the moment. So this work has been undertaken to inform a number of things. So we've taken these sort of societal expectations, which are very much in terms of what people want, and we've gone through a translation process to link that to what we might have in building standards in terms of protection from injury, protection from property, and protection of amenity and function. At the moment, we haven't gone into the different levels of protection, but we're just trying to create what we call an intervention logic to link what the community wants with what our buildings do. As part of that work, we have also looked, the bottom left there is looking at different building types and whether some building types are considered more important to the community than others. And this work is being used to inform and update to our importance levels in New Zealand for understanding which buildings we should have higher building standards for. This work has also informed some of the recent seismic policy updates that I'm sure Ken will talk to you about after me. And we've also done a willingness to pay study to try and understand how much community members are willing to contribute to better performance of buildings. Community engagement. So in New Zealand, community engagement on disaster risk is an increasingly critical element of what we do and how we manage disaster risk. Across New Zealand, we have these things called, there's a network of organisations that bridge between science and practice. They're there to raise awareness of the hazards and to engage communities in preparedness. It's a very disparate system. It's all done by people who are really passionate about these hazards and these locations, and they're all funded in a very ad hoc way, but some of them can create some really great impact. I've provided a QR code there to AF8, which is one of the standouts of these organisations. So AF8 is an organisation that has been working across the South Island of New Zealand to prepare the country, or the South Island, for an alpine fault magnitude 8 event, which has a 75% chance of happening within the next 50 years. And it's likely to affect most of the South Island and probably the lower North Island as well. AF8 have been doing a lot of work with emergency managers across the South Island of New Zealand, helping them to develop preparedness plans and to work with private businesses, critical infrastructure businesses, hospitals, and the like, to help them prepare for this event and think about what they might need to have in place to get through. And they've also done a lot of work with schools and with communities. So they, every year, or it might be twice a year, they take experts from within the science community out to communities, and there's a lot of very small communities around the South Island, and they hold public meetings where they share the science information and they allow a space for people to talk about how prepared they are for these events. Another project I just wanted to quickly highlight is the Let's Talk About Risk program. So taking lessons from the likes of AF8, but also talking to people who work at councils and who are engaging communities about how they manage risk, or how they should manage risk, we realised that they're really difficult conversations to have. So we wanted to capture the best practice for how organisations, in particular councils or local authorities, can talk to communities about natural hazard and climate risk effectively. So helping those who are designing engagements to really understand the context which they're talking in. So are they talking to communities who have recently been affected, or are they talking to communities about a hazard that is long into the future and that people may not believe exists? Are they talking to people who would be directly affected or indirectly affected? So these guidelines really help those people doing engagement to understand who they're talking to, and then and what their response might be to discussions about risk management, and helps them adjust their approach based on the nature of the community. This Let's Talk About Risk team is also shortly, in the next couple of months, going to be releasing, I hope yesterday, releasing some guidance on how to talk about risk tolerance with communities. So that will be coming soon. Well, the last thing I wanted to just talk about was serious games. Now, serious games is something that's growing in popularity in New Zealand for helping to kind of bridge the gap between scientific knowledge and community understanding of hazards. And I would say it's not just being applied to community conversations, it's also being used within critical infrastructure organisations and other organisations that might need to be making decisions about how they manage risk. These games can be physical, they can be online, they can be virtual reality, and they have varying degrees of complexity. So you can just play a game by yourself, or it can be about playing with other people. And really what this is trying to do is to put it into real terms and trying to understand, particularly for hazards that are out into the future, so climate risks, trying to link your decisions that you make today with the potential implications of them into the future. So you are a person, you have a property, and you have bank balances and resources, and then you are forced over time to make decisions based on uncertain information. And you have to make that decision, and then the dice will roll, and that outcome might eventuate, or something else might happen. And so you start to learn about the implications of your decisions now for the future, and I think also get a better understanding of the uncertainty involved in this space as well. So Paula Blackett from University of Waikato has provided those slides for me and does a bit of work in this space. So today I've taken you on a whirlwind tour of quite a broad range of research that's going on in New Zealand, really helping us to put the community at the centre of how we manage disaster risk. So I started off talking about the moving from the direct damage to those indirect impacts, and particularly understanding interdependencies, infrastructure recovery, and societal and economic responses to disruption. But then also looking at the other side around, well, now that we know what the impacts are going to be, what impacts are we willing to accept in terms of understanding our risk tolerance, and also what do our communities want, and how can we have conversations with our community about that risk, about their need to get prepared for it, or their need to decide whether or not they can live with that risk or they want to pay to mitigate it. So, thank you very much. Arigato gozaimasu. It's been a pleasure. Yeah, look forward to opportunities to explore collaboration with you in the future. So thank you.